Alright, well let's wrap up this review with these last couple problems here. Number 17 is giving you 2 out of the 3 roots to a polynomial function, and your job is to come up with the equation that would yield not just these two, but the other missing one. Now, just like the problem that we did, where was it? Right here. See number 16, where we said if 3 plus the square root of 6 is a root, then 3 minus the square root of 6 is a root. Same rules apply here. If we have one of the roots as being negative 4 and the other root being 5i, then what else must also have to be a root? You got it. Negative 5i must be a root or a 0. So we can take the same thing. We flash back here a couple of problems ago. There it is. Oops, went right past it. Computer's not catching up with me. There we go. Remember this one right here? We had zeros of 2, a negative 4, and a 3, and we set that up, and we're able to multiply to come up with the function. These problems are absolutely no different. Okay, so we're doing the exact same thing here again. So let's do it. Except this time, our linear factors would look something like this. We'd have our x plus 4, and then because one of the roots is a negative 5i, we could write x plus 5i, and then if the other root is positive 5i, then we can write x minus 5i. Now, lesson learned here. Okay, pay attention. A lot of students in accelerated algebra are getting burned by this. It's a good idea to multiply those two guys together first. Okay, so let's leave x plus 4 alone for a minute, and let's just FOIL first, outer, inner, last this guy right here. Okay, put it in different colors, put it in blue. So what we will get here, x times x, that's x squared. Outer would be negative 5 times x times I. The inner would just be a positive 5 times x times I. If you remember when we were dealing with these in the videos, those are going to add up to 0xi. That's good news for us. And then here's what happens next. The 5i and the negative 5i would multiply together to give you negative 25i squared. Hopefully some sirens are going off in your head there about the I squared. We're going to do something with that too, right? So that I squared, we're going to do something with that. We're also going to do something here with these two guys because those two guys are like terms. They're going to add up to 0 xi. So I still have x plus 4 still sitting right here. But now inside these parentheses, I got a couple things going on. Number one, I got x squared. Okay, that makes a big 0 right there, so I'm not even going to bother writing it down. But right here we have minus 25, and then recall what I squared is always equal to. If the square root of negative 1 is equal to I, then if I were to square both sides, then I squared would be equal to negative 1. That allows us to substitute. Anytime we see an I squared, we can substitute a negative 1 in its place, which really means what I got going on now is x plus 4, and I'll put it back here in red. I'm getting too excited here. I love math. And then next we would have, just multiply this by x squared, and then a negative 25 times a negative 1 would make that a positive 25. Okay, I'm going to pause right now. This is the time where, see that highlight up there in green? When you are showing your work on test day, if you want to, it is totally okay for you to, when you're showing your work, show this step here first, and then jump straight down here and have x plus 5i times x minus 5i to just be x squared plus 25. I will allow you then, in other words, to skip those two steps right there in red, if you so choose to. You will not get penalized any points there. Okay, but if you want to show that work, go right ahead. So now I just have to multiply those together, and that's a nice little first, outer, inner, last move right there. And if I do that, first times first, shouldn't be too bad, right? If I do that, don't I get x to the third power? And then the outer, I could do outer if I wanted to, but do you notice I would not be writing it in standard form? How about I do the inside next, and then I'd have just 4x squared. And then the outer would be 25x, and then last times last would give me 100, which is what my final answer is anyway. Look at that. Okay, so there's my final answer right there. X to the third plus 4x squared plus 25x plus 100. So, back to the beginning here. Your job on this problem is to come up with that missing zero that was not stated, that missing root, because of the conjugate root theorem. Come up with those linear factors and multiply. I was telling the Accelerated Algebra 2 students this, ladies and gentlemen. This is going to be a 2-point question when you do this on test day. If, and only if, you can get this far, and I'm just talking this far, because it was really frustrating when I was checking students' tests, and because they knew they couldn't do the whole thing, they left it blank, and I couldn't give them any partial credit. Here's what I will say. You do that part right there for me, you get this part down, and you're able to write that part right there, Mr. Cook's going to give you 1 point. You'll get 50% credit just by doing that. Okay? The other 50%, the other point, is you finishing this problem and doing the rest of that stuff right there. Okay? Get that 1 point. Get it. It's not that tricky to get. So just get that 1 point. You might be a difference between a D and an E. Okay? Or a B and a C. Okay? So make sure that you do that. Alright, let's look at this problem here. Number 18. Find all of the zeros. First off, realize because of the number of terms, factoring is not an option here. Also, realize that greatest common factors are not an option here. This is the time where it is our job to find all of those zeros by using the graphing calculator. This is a great place to reference that 5-6 video. Okay, look at those 5-6 videos, and then you'll know exactly what we should be doing on these problems here. So what's our first step? We use the graphing calculator to come up with the real zeros. So let's do that. So first step, type it into the graphing calculator. X to the fourth plus 6x to the third plus 14x squared plus 54x plus 45. That's easy to remember because I think everything was being added here. Sure enough, they were. No subtraction signs there. So as long as I have the numbers all right, a 6, a 14, yep, I'm good to go. Your next move, let's graph it. Take a look at that picture. That picture allows us to estimate approximately where the real zeros are. Looks like we have about 2 of them. They're both negative. So go to your table, and let's get those negative. There's one right there. -1. There's a 0. Let's go get that other one. There's the other one right there. -5. So we found our 2 zeros. Alright, so now that we found our 2 zeros of -5 and -1, let's write those 2 answers down. So x equals -5, x equals -1. Because of the fundamental theorem of algebra, there's 4 solutions here. We are too short. We got to come up with 2 more. Okay? How do we come up with those 2 more? Those 2 other ones that we come up with, we have to do our synthetic division. Okay? We do synthetic division with each one of these zeros. Well, synthetic substitution technically. So grab that -5. Put that right there. Don't change it to the opposite. Keep it the same. Because this is a 0, if I put -5 here and then put those coefficients in there, 1, the 6, the 14, the 54, and the 45, if everything goes well, I should get 0 here. So 1, -5 times 1 gives us -5. Add that up, there's a 1, there's a -5. Add that up, we get 9. That should be -45. 54 minus 45, I believe that's a 9. And then we take -5 times 9, and that should give us -45, which gives us 0 there. Hooray for us. Exactly what should have happened here, because we should get 0 when we plug in -5 into that function. Okay? Here's what happens next. Now, you take that remaining quotient, and you do synthetic division again with the other remaining 0. Okay? So the other remaining 0, which is -1, we do that now with this 1, this 1, this 9, and this 9. If everything goes right, we should get a 0. Bring down the 1. There's -1. Add that up, you get a 0. That should be a 0. Add that up, that's a 9. Negative 1 times 9 makes negative 9. And booyah! There's the 0 right there. So what the heck are we looking at right here? What you are looking at right there is we have just now used the linear factors of, let's see, x plus 5 and x plus 1. And now we're just trying to figure out just what else we need to multiply this by. 1, 2, 3, 4. Multiply those 4 linear factors together to get that quadratic right there. That's pretty much what we're doing. And if we set all those equal to 0, we could find the solution. Now, what are we looking at right here? Aren't we really looking at, we took a 4th degree and dropped that down to a 3rd degree, just like that. And now doing division again, now it's 2nd degree. That's x squared plus 0x plus 9. In other words, x squared plus 9 must be equal to 0. This is the algebra problem we need to solve, which is pretty solvable, isn't it? And then what's our next move? Take the square root on both sides. And so here comes our first and second answer of plus minus 3i, right? So there's one answer, positive 3i, and the other answer, negative 3i. Those are all 4 of our solutions right there, okay? And that's how we roll on those problems. Let's take a look at the final problem. This one here comes from 5-9. If I wanted to take the parent function x to the 3rd, and let's do a vertical stretch by a factor of 6, a horizontal shift 4 to the right, and a vertical shift of 4 units down, absolutely no different from any of the other lessons we've done in the first trimester. In other words, do you know what number should go right there in that first spot? I hope so, because if it said we do a vertical stretch by a factor of 6, we know where the vertical stretch number needs to go. It needs to go right there. Right? So there's a 6. Now, if we move horizontally 4 to the right, remember horizontally, opposite game, so 4 to the right, we can move it 4 to the right, put it in the parentheses, that should be minus 4. And then if we want to move a vertical shift of 4 units down, that's a same game going on right there. So that 4, you got it, minus 4. And we've just written that function. That'll be multiple choice. Shouldn't be any easier than that. All right. So, ladies and gentlemen, that is your test. If you have any questions whatsoever, please feel free to email me. And remember, homework, get that homework into Mrs. Regal on the 18th before break, and do the best you can on that test. Okay? Good luck, everybody, and I will see you guys in January.